All right, welcome back. So now that we have our understanding of uniform distributions and how they relate to probability, let's see how we could do that for a bell-shaped curve. In order to do that, we're going to need to standardize it because not all bell-shaped curves are going to have an area of 1 underneath it. So what conditions are we going to need? And there's two important pieces. The first piece is that the mean is going to have to be 0. If the mean is 0, that's a good part of it, but then the standard deviation is also going to have to equal 1. So when those two conditions are going on, and of course it's bell-shaped, then it's considered a standard normal distribution. And we know that the area under the density curve is equal to 1. So we would have something that looks like this. When that happens, then we can use a couple of tables that are in the back of your book. So table A2 from Appendix A, or using the formula and tables insert card. So you have it on the insert card, and you have it in the appendix, and you also have it in the back of your textbook as well. The back cover are your tables as well. So we're going to use those to analyze 3 different cases of probability problems. So let's go through all of those. Now, the one thing to keep in mind about table A2 is that it only shows area under the curve to the left of the z-score. Now, we're going to get to the z-scores and all that stuff as we go. But the big thing is the number in question, the value in question is always, the table always looks to the left of it. So we're going to have to see how to manipulate it when we're talking about to the right or otherwise. So let's start with that first case. If it's shaded to the left, we can use the tables directly, and it's a nice process. So the probability that z is less than a. So this denotes the probability that the z-score is less than a. So we would have our bell-shaped curve. Again, we're looking at a specific value of a. So a is just a number somewhere on this number line. That's all a is. So I'm going to say, let's pretend a is over here. So this is where z is equal to a, and I'm going to be shading on the left-hand side. So there's my picture. Now, the one nice thing about the picture is that from this, again, think area and probabilities go hand in hand. How much have I shaded of the whole bell? If I know the whole bell is equal to 1 and a is over here, I know the probability better be more than half, right? Because I've shaded more than half the bell. So that's why the picture is so important, because it kind of gives you an indicator of, do I have more than a half shaded or less than a half shaded? And so your answer should correlate with that. And if it doesn't, then there's something wrong. So we'll see all this in action, so just bear with me. Let's look at a specific example. Probability that z is less than 1.27. So the first thing we know is that positive 1.27 better be on the right-hand side of 0, because 0 is in the middle. So it's going to have to be over here. I know it's a little hard to see, but that's where we are, and then we know we're shading on this side. So how do we use the table to get our answer? The answer, it's hard to see, but it's 0.8980. Now, how did they get that from the table? Well, there's a little cutout from the table, and I'm going to pull up the table and show you exactly how to do it as well. But the big thing to keep in mind is that the table breaks apart your z-score into 2 components. So you got the first digit, the decimal point, and the 0. So in this case, 1.27, we want the 1.2 part. Let me write this a little bigger. So the 1.2 part is what's going to be on the left-hand side that we're looking for. So we have to go all the way down to 1.2. So now we know we're in this row somewhere. But the 7 part is the second decimal place. So that's what you're looking for here. So all they do is count the second decimal place. So we're looking for we don't care that there's a 0 here, because we already took care of the 2 part down here. So we want just the 7 part to correspond to that 7. So that means we have to look in this column. So now we can cross-reference those two, And there's that 0.8980. Once you've got that, you're done. So just to see it from the whole table perspective. So here's the whole table. And so now let's do it again. So we need to go all the way down to 1.2, and then we need the 7. So we're just going to cross-reference it down, and then here we are underneath the 0.07. So again, the 7 is the second decimal place. So 0.8980, and there's our answer. Done. So that's the first case, but let's just do one more just to really sink it home. So we got find the following probability that z is less than negative 0.87. Now, they could put it in words, they could use inequalities, it all means the same thing. Less than means left, it's shaded to the left. But there's two tables in your book. So which table are you looking at? Look at our z-score, negative 0.87. So we have a positive table and we have a negative table. So we want to use the negative one. So let's toss away the positive. Now the setup is the same. You will still want that first digit, the decimal point, and then the first decimal place. So we need negative 0.08. So right down to here. And now we want to get the 7. So let me see if I can get the 7. You can see it. So there's the 7. So we want to cross-reference these two. It looks like 0.1922 should be our answer. So 0.1922 should be our answer. Now, let's just draw a picture just to make sure it looks right based on our picture. Now we know 0's in the middle, but now our z-score is negative, so we know we're going to have to be over on the left-hand side. And because it's less than, we know we had a shade on the left. So again, does 0.1922, so roughly 19.22%, does that look about that size? Yeah, sure. Sure, we're on the left-hand side. It is smaller than 50%, so we know that at least makes sense. So that's the kind of checks that you want to do with these problems and why the pictures are so important. All right? Okay. So let's see how much time's gone by. 8 minutes. Well, let's stop, absorb that, and we'll look at the other examples in upcoming videos. So see you in a minute.